Alright, for this next video, we're going to discuss our second measure of spread or variability, and that is called the standard deviation. And much like the mean is our gold standard for measures of center, the standard deviation is our gold standard for measures of spread. And what the standard deviation is measuring is the average So we look at the whole data set. I look at how far each data point is from the mean. I go through an averaging process to look at the average distance from the mean. The bigger this measure is, the farther my data points are from the mean on average, the more spread out my data set is. The smaller this measure is, the smaller that average distance from the mean, the closer my data is to the center of the graph on average. Much like the mean, we have two formulas with some new symbols to calculate the population standard deviation and the sample standard deviation. Unlike the mean, where the structure of the formula was identical for both, here there's a small change between sample and population. So it is super important for standard deviation. You know whether you're calculating a population parameter or a sample statistic. 99.9% of the time in statistics, we are calculating a sample statistic, a sample standard deviation. So unless you are told otherwise, it is generally safe to assume you're looking at a sample standard deviation. The one exception is for probability distributions, which we'll see in another week or so. So let's go ahead and take a look at the formula for standard deviation. We'll start with the sample value. The symbol we're going to use for standard deviation. Your calculator x, because we're looking at the standard deviation of x values. I know that what I'm doing is I'm looking at the distance from the mean for each data value and then averaging it out. So the distance from the mean would be the data value minus the mean. And then I know to average those values up. Whoops. And I divide by the values that I have. And here's where it gets a little weird. First, for the sample standard deviation, we're not going to divide by sample size n. We're going to divide by n minus 1. And there's some interesting higher level math here as to why we do this. And if you're curious, I can send you an article about it. But that is way beyond the scope of our class. So for now, it's just helpful to know. The problem is if I do the formula this way, them all up, will always add to 0 because I know that the mean is the pivot point. And if I were to add up all the deviations, the distances from the means, the guys that are less than will be negative, greater than will be positive, and they should exactly cancel. So how do I fix that problem? The answer is I want to get rid of the negatives, and I know I can do that by squaring a number. Negative times negative gives me positive. But if I've squared something, I need to undo it. So after we've taken the deviations, squared them, added them up, and divided, the last step to our standard deviation. This is our sample. For the population, that same pattern, we're going to use a Greek letter to represent the population standard deviation, and we're going to use the Greek letter sigma. And this is lowercase sigma. We know what uppercase sigma looks like because we have it here. Uppercase sigma means add. So this is lowercase sigma. And the formula is very similar. Square root the sum of the data values minus the mean, and in this case I have the population value. Square those deviations. And then instead of dividing by sample size minus 1, I'm dividing by the population size. So capital N is the population size. Lowercase n is the sample size. How many data values are in that list? So this is the population standard deviation. And you will notice I'm using SD for short. It is also okay to write SD when you're writing out a sentence, but when you're doing the appropriate symbol, so it's very clear that we're talking about sample versus population. The easy way to do this is to put the data in list 1 on your calculator and then run 1-bar stats. The same way that we have been finding all of the other values with a calculator. What I want to show you is how to do it by hand, because I think that's a useful skill to have, and some people actually prefer to do this. So if I want to do a standard deviation calculator by hand, what I'm going to do is I'm going to set up a table, and I'm going to babysit my way through this calculation. So first thing I need to do is I need a list of my x's, and I need to calculate my mean. So x, and then I'm going to list my values. I have 1, 3, 6, 7, 7, 9, 12, 15, and 20. My next box, I need to find the deviation, distance from the mean. So I'm going to do x bar. I know my mean is the sum of the values, divided by the number of values. So I'm going to add these guys up. And I have, let's see, 20, that's 35, 47, 56, 63, 70, 76, 79, 82, 83. So my mean should be 83 divided by 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Or 8.3. So here, I'm and I'm going to do this off to the side on my calculator really quick. Please don't judge me. My poor little brain is fried. So 1 minus 8.3, maybe. Here. 5.3, -2.3, -1.3, -1.3, 9 minus 8, 7, 7, and 11. I go back and look at my formula. Next step, after I've subtracted, I found my deviation, I'm going to square, and I'm going to add. So I need one more column for the squares of the deviations. So I'm going to extend this over a little bit. And I want x minus x bar squared. So 7.3 squared is 53.29. 5 2.3 squared is 28.09. 2.3 squared is 5.29. And so on down the list. Whoops. So next step, I go back up to my formula. I found the deviation. I squared it. Now I'm going to add those values up. So patience while I type this all in my handheld calculator here.
Why are they not just going any point backward or down? I don't understand.
And when I did it, I got 314.1. You definitely should check my math and make sure I did that correctly. From here, I can plug into my formula. So my standard deviation is square root of the sum of the squares of the deviations, 314.1, divided by n minus 1. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 10 minus 1. And then take a square root. So this is going to be the square root of 314.1 divided by 9, which is 34.9. And then I'm going to take the square root of that. And when I do that, I get 5.9. And I'm rounding that to one decimal place because all of my original data was whole numbers. And generally, I like to round to one place past the original data. So the average distance from the mean for this set of data is 5.9 units. Again, a reminder, you do not have to do this. This is not required. I'm never going to ask you to do this on a test. This is a perfectly acceptable measure, or method rather. What you do need to understand is bigger means more spread out, smaller means less spread out, and being able to differentiate between sample versus population. All right, if you have any questions on standard deviation or how to calculate standard deviation, feel free to send me an email. Otherwise, I will see you in our next video.